28th. Your final is the 27th. And so usually I do 3 days of review for final. So if you count that Tuesday, which you still will be in here, technically, we might not start our review for final until like the 21st, the 20th or the 21st. So there's no need to spend 7 days reviewing for a final. There's not that much stuff, right? If you remember from first semester, I gave you like 3 days of problems to do, about 20 problems a day, and that's the material that you focused on. We're not going to spend 7 days reviewing in class. Like, there's just no need to do that. I can barely get you to listen to me.
So what would you do if we do it?
I don't know. We'll figure it out. Test corrections?
That's only 1 day though.
And then we can start reviewing on the 21st. It'll be good. Don't worry. How about, the answer to your question is, Maddie, we are not going to have a test on the same day as an AP test. Okay? But let's focus on parabolas. We know what a parabola is. We've learned about parabolas since Algebra 1. Boys. Quadratic equations are parabolas. We know it's a U-shaped graph, but talking about conic sections, we're going to talk about everything being like equidistant from something. The definition of a circle is that all points in a circle are equidistant from the same point, the center. For a parabola, we say a parabola is a set of all points in a plane that are equidistant from a fixed line, called the directrix, and a fixed point, called the focus, that is not on the line. I'm going to draw a really bad picture here, but just to kind of show you what I mean, if I have a parabola, does it annoy you when my pins are in the wrong spot?
Yes.
I am recording.
Okay, sure.
When I have a parabola, the line behind it that it's equidistant from is called the directrix. So there'll be some line back here, like this, the directrix. And there'll be some point inside the parabola called the focus. The focus. That every point on that parabola will be equidistant from. The easiest one to measure, which mine does not look that equal, but the easiest one to measure is the one that's straight through, because you can measure distance vertically like this, and you can say that this distance is supposed to be the same as this distance, which doesn't quite look like that on mine. But it's true for every point on the parabola. But remember, to measure distance, it has to be a perpendicular, so it kind of gets a little messy to draw those in. But that's the definition. So when we're talking about these today, instead of graphing them by just doing an XY chart, which you could always do, we're going to talk about how we can use the focus and the directrix, or maybe the focal width, which would be like this distance away, this distance away. I'm going to show you maybe some shortcuts to graphing. The other thing that we're going to talk about is we're not only going to talk about parabolas that can open up and down, but we're going to talk about parabolas that open side to side. And again, those are going to have a directrix and a focus. The directrix is always a line behind it. So if your graph opens up or down, your directrix is always horizontal. If it opens side to side, your directrix is going to be vertical. And your focus is always inside the parabola. And again, those distances are supposed to be equal. And so there's a formula for that, and it looks a little scary when we fill this all out, because it seems like, how am I ever going to memorize all that? You don't have to memorize it all. You have to know the basic formula, and you have to understand what we do to get the focus and the directrix, and then you really just fill the rest in using what you know about that. Okay, and so I think I'm going to have this picture on the next one, on the next slide here. See, look, I gave you both of them. They talk about D here for directrix, but your book doesn't use that. Are your equations squished like this on your paper?
No.
Why does my computer, when I save it, change it? Who can tell me the answer to that? Like, it's perfect. I print it, and then I hit save, and it's not right. Have you tried punching your smartboard? Okay, so I'm going to give you two lists of this, just because I think sometimes if you talk about the vertex being at 0, 0, it's easier to kind of see where this comes from. And then we're going to talk about what if the vertex isn't at the origin. That just means we're going to throw in an h and a k, just like we did with a circle. All right, so notice there's this p value in here, and that's going to become important later. If the x is squared and the y isn't, then your parabola is always going to open up or down. Probably not the form of a parabola that we think of, but and if the y is squared and the x isn't, then that's not a function, and that's going to open left or right. how do you know whether it's left or right or up or down? Remember the negative, right? If there's a negative, that's going to be a reflection. The focus and the directrix, that's what we want to work with. And the focus is where the P value comes into play here. And so the focus, if your vertex is at 0, 0, and it's opening up or down, the focus is going to be that point inside the parabola. And so it means that you're still going to be at 0 on the x, but you're going to be at P units away from that. And so that's why using this form of the equation is very useful, because if you can figure out what P is, you know where the focus is. And the directrix is an equation, and it's going to be a horizontal equation on this, so it's going to be y equals, and it's the same distance away, only in the opposite direction, so it's y equals negative P. And if you go side to side, same thing, only if it's going side to side, now your focus is a horizontal distance away. So that means that it's going to be P0 instead of 0P. And your directrix is now vertical, but it's still going to be x equals negative P. If you, when you say directrix, you have to write an equation. Just like when we say the axis of symmetry is the line that cuts it in half, you have to say an equation. Can you complain a little bit more?
I was actually complaining. I could have gone to that.
The axis of symmetry is the line that cuts it right in half. If it is at the origin, right, then it's just the y-axis. I really need to fix this board. It's not calibrated very well. Zane, stop. And if it's opening this way, it would be y equals 0. Axis symmetry, I threw it in there just because we've talked about it before, but you don't really need the axis symmetry when you're graphing these. What we really care about is this focal length and focal width. I kind of was getting mixed up of which one. Focal length is just how far is it from the focus to the vertex. So let's write that. From focus to vertex is just P units away. The focal width, which has this lovely Latin name called the latus rectum, and everyone can laugh because we said rectum.
Not bad.
That's going to be what helps us graph really easily. And it's going to be the absolute value of 4p. Which, notice, 4p is right here. So if you have it in this form of the equation, I'm going to show you a really quick way to graph. Worst case scenario, you make an XY chart and you get a parabola and it works that way. But I want to show you why is it helpful to look at conic sections like this. Kind of makes it easier to graph. Does that look a little scary? Find the vertex, the focus, the directrix, and the focal width of the parabola. Step 1, before you start using those things, you want to put it in the right form. And the right form, if you look on the previous page, is you get the squared term by itself, yes?
Yes.
So what would I need to do to get the squared term by itself? Just going to divide by 5. Now, not a very pretty equation here. Y squared equals 16 fifths x. Since the y is squared, which way is this opening? More specifically, which way? Right, because it's positive. Right? If there was a negative in there, it would be opening to the left. Which means I'm using the second column of stuff that I wrote out. Y squared equals 4px. In order to do the focus, the directrix, the focal width, you have to know what p is. So it's really important that we know that 4p is what's in front of x. So to solve for p, do you agree that I would just set 16 over 5 equal to 4p? Because 4p is what's in front of x. Sometimes it's really easy. Like if it was 8x, you would know, oh, p is 2, because 4 times 2 is 8. Sometimes it's kind of ugly, right? And you might have to do some math. Dividing by 4, and remember dividing by 4 is like the same as if you know P, you know everything. Meaning if you know what the list on the other side is. My advice to you is, don't make this list that we just made on the other side a crutch, right? Try to think about it as you do your homework problems today before you just have this right in front of you staring at it, not thinking where things are coming from. Because I'm not letting you use this on your test. Super mean, right? So, vertex. Right now, we only have one equation for a vertex. What is our vertex every time right now? The origin, right? 0, 0, like that's all of them. So in a minute, I'm going to show you the other ones. Or maybe you've looked ahead and saw them. But the vertex is at 0, 0. The focus is the point inside the parabola, p units away. So if it's opening to the right, if you get confused, right? Like on the test, you're like, I don't know which one to put the 4/5 in. Do I put it in the first or the second, the x or the y? Think about that it's inside, calibrate this, it's inside the parabola, so it's 4/5 horizontally. So that would be 4/5, 0. The y doesn't change. The directrix is the line directly behind the parabola, the same distance away as the focus. It's just negative, right? So that's why the equation is negative p. Because if this is positive p, we're going to go back 4/5 units. If it's a vertical line, is it x equals or y equals? X equals negative 4/5. And the focal width, which I guess we should have written out what that means. The focal width is the distance through the focus. That's really off. The distance that goes through the focus that touches the side of the parabola. Does that make sense? Distance through, I'm going to spell through wrong, through the focus touching sides of parabola. I'm going to do this really quick since I'm going to graph in a second. Distance through the focus touching the edges of the parabola. Okay. And it's just the absolute value of 4p. Which means we could just take p times 4 again, or that's just 4p. Right? Or just take p times 4. So the focal width equals the absolute value of 4p, which is just 16 over 5. Why didn't I make us graph this one? Because that's really not that much fun to graph 16/5 and 4/5. We could, but it's just not that much. Not that much fun. So maybe we can grab some better ones. Okay, ready? Not ready. You are ready. Y squared equals negative 8x. Which way is this going to open? Left, because the y is squared and it's negative. On a test, could you just make an XY chart and graph this? You could. What would make more sense to pick first on this? Would you pick x's or would you pick y's? Yeah.
I just want to contradict you.
Well, if you pick x, then you just have to take the square root of it, right? Because y squared, it'd be plus or minus. I think y is the smarter thing to do, but I think I'm going to show you a better way to graph, okay? So let's figure this out. Vertex, what's our vertex? Yeah, 0, 0. What is p? Or how could I find what p is? 4p equals what's in front of here, so 4p equals negative 8. So p equals negative 2. So that means my focus, if my vertex is right here, and it's opening to the left, that means my focus is negative 2, 0 right there. Does that make sense? So my focus would be negative 2, 0. from. So you take that distance of 8, and you just make that 8. So you go 4 up, 4 down, and that is your parabola using your focal width. And you never had to make an XY chart and square root both sides if you picked x's first.
I didn't mind this the first time we were graphing parabolas.
Because then you would be scared about focuses and directrixes. I don't think that's right to say. It is way easier, right? The directrix, if you wanted to say where it was, is the exact same distance behind the parabola. So if it's 2 this way, then I know my directrix is going to go through here. But remember, it's a line. And so if you don't have to draw that in unless the direction said to. But just to kind of show you, that's what the focus and the directrix is. The directrix doesn't really help us, but that's where the definition comes from, that all the points on the parabola are equidistant from that. And you can check these points. That's 4 units from the directrix, and it's 4 units from the focus. What about this if I gave you a fraction? Can we do that one? Which way is it going to open? Down. Could you just make an XY chart here? You could. But my vertex is still at 0, 0. What would P be in this one? Oh. If we want to use the formula, isn't the formula x squared equals 4py? Oh, so if we're going to use the shortcut way, we have to make sure we have it in the right form. So I would multiply both sides by -6. So I could say x squared equals -6y.
Why is vertex always
Right now it's always 0, 0 because there's nothing added or subtracted. But on the next slide, looking ahead,
there will be?
if there's something added or subtracted in parentheses with x and y, that's going to be your HK, and that's going to move the vertex. But right now we're starting slow. Just one slide away, and I'm doing this with but that's why it's 0, 0, because there's nothing added to x and y. So be careful, right? Don't jump straight to 4p. You have to make sure that it's in the right form. And the right form is getting the squared term by itself. The vertex is still at 0, 0. But now to find p, this is going to change our p value. 4p equals -6. So p equals a fraction. Oh, oops, just kidding. Sometimes my brain says one thing and my hand writes the other thing. -3/2.
Yeah.
What? Ah, yes, that's true. So here's what I want to tell you. My Math 137 kids are feeling very overwhelmed right now because they feel like they're supposed to be memorizing a million things. I don't memorize these formulas. I just know what it means to be the focus. The focus is p units away from the vertex. So since this is -3/2, I know my focus is -1/2 down. And it kind of verifies that it opens down. What's my focal width? Right? Absolute value, it's distance, so that's why it's absolute value. So my focal width is 6. So what do I do from my focus? 3 each way. So, and again, if you wanted to graph your directrix, that would be the line right behind it. And again, you can check that they should be equidistant from here, and if you check from here, it should be the same distance from the focus as it is from the directrix. Kind of a quick way of graphing parabolas, right? So, how can it look scarier? What if the vertex is not at 0, 0? Just like the center of a circle is at HK, we can say the vertex is at 0, 0 here because we have x minus 0 squared, y minus 0 squared. But what if we threw an hk in there? It looks a little scarier, but the process is the same. So I filled this out for you. Hopefully it's all filled out really nice for you. Same format, all I've done is added in a vertex at hk instead of at 0, 0. So if you see something added or subtracted there, it just means that it's not at 0 anymore. It's moved, translated left or right or up or down or both. So you'll notice that the formulas look a little crazier here. Vertical axis, that's the axis of symmetry. Your book calls it the vertical axis. That's just x equals h. The directrix is now y equals k minus p, right? Like it was y equals negative p, but now we have to start at the vertex and go from there. And the same thing for the focus. You have to start at the vertex and then move p units. Again, I don't stress about making index cards and memorizing this because I know what it means to be a focus, and I just have to think about, okay, which one am I doing this to, and I'm adding it to k or I'm adding it to h to get there. The focal width hasn't changed. It's still 4p. And so then notice if the y is squared, it's just going to switch everything, right? The directrix is now the vertical line, x equals, the focus, you're adding that to h instead of k. It looks really overwhelming, but if you understand the process, all you have to do is find your vertex, find p, and move that many units away. So let's look at a couple more, and then we'll be done. Good. Again, step 1 is going to be put it in the right form so that you make sure that you're finding p correctly. And the right form is to get what by itself? The squared part. So I'm just going to subtract this over and say x minus 1 squared equals negative 8, y plus 2. So step 1, which way is this going to open? If x is squared, it's opening up or down. Since it's negative, that means it's opening down.
Up, down. This step I knew was up, down. That's a step in the right direction.
Yes?
Because the negative 8's negative, yeah, but the x screw.
But the negative, if there's a negative, it's going to be down, right?
I'm kind of, no, it kind of makes sense to me too, because, like, when it's, well, I guess.
If I solved it out and then solved for y, then the x would be negative, because I'd have to divide that negative 8 over at some point. You see what I'm saying? Like, you're thinking old quadratics, like, you're thinking, normally it's like y equals ax squared plus bx plus c, right? This is what you've learned since algebra 1, and you've learned if a is positive, it opens up, if a is negative, it opens down. That's true. But we're not solving for y in this, right? Like, if we did solve for y, we would FOIL this all out, and we have to divide by negative 8, which means that x squared would be negative. In this form, if your 4p value is negative, that's what's telling you it's opening down or it's opening to the left. Does that make sense? Okay. See, that's the tricky part about learning quadratics in a different way. Okay. What is my vertex?
That's 1 negative.
1 negative 2.
Yeah, and then remember, it's just like circles, x minus h, y minus k, so it's opposite 1, negative 2. What is p? Right, this is still 4p, so 4p equals negative 8, so p equals negative 2. I want to show you how we can use the graph instead of thinking about the formula, and then I'll show you how the formula just fits right there to it. If you're good with formulas and you want to just say, I know exactly what to add here to get this, but if you know which way it opens and you know what it means for the focus, you're going to be able to find that point really easily. Because my vertex is now at 1, negative 2, and I know it's opening down, right? So if it's opening down, which way am I going to go for my focus? Up, down, left, right? Down, and how many units am I going to go down? 2, because p is negative 2. The focus is p units from the vertex. So that means my focus is right there. For me, the graph helps me think about, okay, which one is changing? The y value is changing, and I'm going to add p to that y value. So if you write it as a formula, the focus is that the h doesn't change, and we take k 2 minus 2 gives me 1, -4, which is exactly what I got very quickly by graphing it. I just want you to be able to find the focus, whether you find it from graphing it or you find it by having a formula. To me, it makes more sense to understand just move p units away in the direction that it opens to get your focus. What else did they ask us to find? The directrix. Again, you can just know the formula, or you can know what it means to be the directrix. Directrix is the line directly behind it, so if this is opening down, I know that's going to be a horizontal line, and it's going to be p units the other way, right? So if I went 2 units down this way, the directrix is going to be 2 units up this way, which would just be the line y equals 0. How could you get that from the formula? It's k minus p, right? Which is -2 minus -2, which is y equals 0. If we're going to graph this, we need the focal width. What's the focal width? +8, but that's okay. And so that just means from my focus, I'm going to go half of the focal width on each side. So again, I'm going to go 4 on each side. What's 4? Okay. And again, a nice way to check is that if you count from your focus over to that point and up to your directrix, it's always going to be the same distance because that's the definition of a parabola. That's really kind of as ugly as it looks. I just don't want you to get bombarded and feel overwhelmed by the formulas. What's the one other thing I could give you is completing the square. All of these conic sections, they're going to give you some that aren't in the right form. So last one here, it says write the equation in standard form, state the vertex, focus, and directrix, and graph. Just like with circles, if you see that there is the squared term, and then there's that y to the first power, you have to write it as y minus k squared, which means you're going to have to complete the square. It's up to you in what order you want to do this in. If you know the y squared has to be by itself, we could go ahead and move this to the other side. We could complete the square and then move the stuff to the other side. It's kind of whatever you want to do. But if y is squared, the formula is y minus k squared equals 4p times x minus h. So I'm going to get the y's by themselves and move everything else to the other side. So I'm going to say y squared minus 2y. I'm going to leave the space to complete the square, and then that would become -4x plus 11 on the other side. And then what am I going to fill in there? Plus 1, right? Half of -2 is -1 squared is plus 1, which means I have to add 1 to the other side to keep it balanced. So I'm going to get y minus 1 squared equals -4x plus 12. Is that in standard form? Yeah, we need that 4p out front. So we need to factor out whatever the common factor is to get that. And so it should be that these have a common factor among them. Otherwise it would get really ugly. And so since we need this as a positive x, that means we should factor out the -4. And we would get x minus 3. With me on that? Be really careful. Here's the mistake that I make a lot. I want to say the vertex is 1, 3. But that's not right, because why? No.
I'm lost, I don't know.
You would say the vertex is 1, 3?
No, it's 1, -3. 3, 1, 3, 1.
It's HK, right? And I'm so used, I just want to take the first parenthesis and the second parenthesis. But K is with Y and H is with X. So it's really easy to mix those all up. But H is the X coordinate of the vertex. So it's really 3, 1. The negative has nothing to do with the vertex. It just means we're going to open down. All right, so just be really careful. It's easy to make that mistake in a hurry, especially especially when I don't give you the formulas to look at. 3, 1. What is P in this one? It's just negative 1, right? 4P equals negative 4, so P equals negative 1. So where's my focus going to be? Up, down, left, right?
Down.
Right? This is what you have to know to do the focus if you don't have the formula memorized. If y is squared, right? Y is squared. Which way is this opening? What are my options? Up and down or left and right? It's got to be left or right. Because it's negative, it's got to be left. You have to know that, which is why it makes you really think instead of just staring at a formula page and writing it all down. You have to think, oh, it's to the left, so I'm just going to go to the left 1 unit. Which means my directrix would be to the right 1 unit and that vertical line right there. So if the question didn't say graph, I would still sketch the graph. Like, I'd maybe not do the whole thing, but I would do this because I could see from here, I can just look at it and say the focus is just 1 to the left from the vertex, which means that that's just 2, 1. And the directrix is the line x equals 1 to the other way, which means that's just at 4, x equals 4. I don't have those formulas memorized. I just use what I know to get them. And that's my suggestion to you, because I'm going to keep giving you formulas like this for the next 2 days, well, for tomorrow and then Monday, and it's a lot, so don't feel like you have to memorize them. If I was going to graph this one, the focal width is 4p, which means the focal width is 4, so I'm just going to go from my focus up to, down to. But you have to know which direction it opens in, or you're going to get everything mixed up. Questions about this? Okay. Looking in your book, I picked 5. I think it just asks you to list like the vertex and the focus and the directrix. 7 through 10 are matching an equation with graphs, so those shouldn't be so bad. And then the next 6, some of them are graphing, some